So here's my idea today. I'm going to do the same thing I've done two times now, and it's the idea of just talking without stopping. And this pretty much forces me to talk about what I'm thinking, right? And what I'm thinking about now is how Kant's philosophy, Kantian philosophy is wrong, and I really think that's a boring subject for now, and I really want to get into another subject. I've been thinking that maybe this whole idea of this analysis about subjects is in itself a field, if I am allowed to say that. It's a field of activity, and should I say that philosophy is the same as studying the history of philosophy? Certainly, I'm not allowed to say that. And should I say that studying the history of philosophy is the same as critically thinking about philosophy? I'm also not allowed to say that. And that's my point here. What we're doing is we are bringing up ideas and we verifying them. We're not interested in memorizing the ideas themselves if they're wrong. We are only interested in the truth here. And there's a book by Kant, Immanuel Kant, that's called The Critique of Judgment. And I don't like Kant's titles. And I've had the opportunity to talk with someone who studies Kant for at least 4 years from today. And we had a very intense discussion about Kant's ideas. And my point here is that Kant is wrong. Kant is wrong, and the whole idea that Kant can introduce how each subjective moral should be is an idea of morality. Right? Maybe Kant is talking about two kinds of morality. The morality that interests people in a situation where they have to worry about how other people around them react to their actions, and the tautological morality, in which you just believe something is right or wrong. And my friend there was he started making a confusion between the two, and then he said that the first case is not morality, and the second one is morality. And then he went on to say, come on, man, all you have to do is to think about how subjective your morality is, and all you have to do from there is to try to be consistent with yourself. And I have to say that it's really obvious to me that what Kant is saying here is that it's wrong to be inconsistent with your own morality, and it's right to be consistent with your own morality. So that's a morality. That's my point here. And maybe that's enough about Kant, right? I should probably just read more until I'm able to make more commentary. But about these things, I'm pretty sure I'm in the right position here. Yeah, alright. So I'm thinking about giving a small read on Newton's Principia from the Latin word. And let's see. Isaac Newton, Cambridge, Trinity College, May 8, 1688. That's the date. And contents. Definitions. First page. Definition 1. The quantity of matter is the measure of a same. Wow. Arising from its density and bulk conjunctly. So he starts saying that quantity of matter is measure of matter, and it comes from its density and bulk is volume, right? So matter comes from density and volume. Does air of a double density in a double that's what he says. Does air of a double density in a double space is quadruple in quantity. Do you understand that matter arises from density and bulk? If you have twice as much volume with the same density, you have twice the same mass. So what he says here is, if you double the density and if you double the space, the volume, you have the quadruple of the quantity, 4 times the quantity. The quantity is 4-fold, right? You multiply it by 4. in a triple space sextuple in quantity. Yeah, so on and so on. And definition 2. The quantity of motion is the measure of the same, arising from the velocity and quantity of matter conjunctly. This is... let me see how I talk about this. This is momentum. Yeah, this is momentum. I don't think that Sir Isaac Newton had the idea of energy. What he had instead was the idea of quantity of motion. And quantity of motion is multiplication of matter and velocity. And as I read here, he's not using any mathematical notation. He's just saying here in plain English syntax. Right. Definition 3. Definition 3 is about inertia. And he starts with a reference to Latin that is vis incita. So he goes on, the vis incita, or innate force of matter, is a power of resisting by which every body, as much as in it lies, endeavors to persevere in its present state. Its state, not state, state, whether it be of rest or of moving uniformly forward in a right line. Definition 4. An impressed force is an action exerted upon a body in order to change its state, either of rest or of moving uniformity forward in a right line. He talks about if a body is not moving or moving, it's always in a forward line, right? This force consists in the action only and remains no longer in the body when the action is over, for the body maintains every new state it acquires, but it's by its vis inertia only. Impressed forces are of different origins, as from percussion, from pressure, from centripetal force. Remember that now he's talking about inertia. And inertia is the same as vis incita, because he says about definition 3, which is about inertia, this. But it should be called, upon which account this vis incita, by a most significant name, be called vis inertia, or force of inactivity. Right. Definition 5. A centripetal force is that by which bodies are drawn or impelled, or any way tend towards a point as to a center. Right. Definition 6. The absolute quantity of a centripetal force is the measure of the same proportional to the efficacy of the cause that propagates it from the center through the spaces round about. Definition 7. The accelerative quantity of a centripetal force is the measure of the same proportional to the velocity which it generates in a given time. Right. Definition 8. The motive quantity of a centripetal force is the measure of the same proportional to the motion which it generates in a given time. And then it's the end of definitions, it seems. Next part is called scholium, which probably comes from Latin, and I don't know what it means. Alright. Alright. 1 minute left in chapter, and the next chapter is axioms, or laws of motion. And there is law 1, law 2, law 3, corollary 1, and corollary 2, and let's go on. Corollary 3, 4, 5, 6, scholium. Scholium must be like the conclusion, I believe. And it's a very long, maybe it's the main part of the text. Let's look it up. Scholium must be easy to find on the internet. The scholia, not to be confused with scholium. Scholia are a grammatical, critical, or explanatory comments. So I think what Newton is doing here is he's making definitions and then he's making an explanatory note or commentary. Yeah, I think that's enough about Newton and Principia. And my mechanics teacher recommended me to read this, and certainly I will read it, and I have to read it first. I'm not liking the book so far because mostly I know what it is about. You know, there's this paradox, right? If you don't know what the book's talking about, you should probably be interested, and if you know, what the subject is, you should also be interested. But what I see is the opposite. When you don't know what the book's talking about, you are like, oh man, I don't know about this, so I don't care. And when you know about the subject, you feel like, wow man, this is a waste of time. It seems that you just don't want to read it, right? And I get that from time to time. I don't think it's a major problem. Let's see. So there's another book, and my main focus here is to make a very sound criticism, because I want people to be happy, and if they are believing in lies, then I don't think they will be happy. And this book is horrible, man. It has the goal to explain why and just why basically do we have 3 dimensions in physics. And so far it's like I'm 14% into the book, and it's just talking bullshit. It's talking about how prime numbers are cool and the natural number, and it's teaching me something that I don't agree with, like infinite series. And then it mentions the Occam's razor, and then it says that naturalness plus the Occam's razor regulates the dimensions from up to down. So if you are to choose between 7 dimensions and 6 dimensions, Occam's razor and naturalness, which I don't know what is it. What is naturalness? I do understand Occam's razor. Yeah, it's a very, I don't know, it's at least functional. But what's naturalness? I don't think I know. And then it says that if you're choosing between like 7 and 6 dimensions, you should choose 6 by naturalness and Occam's razor. And then it says that if you're choosing from like 1 to 2 dimensions, there is something that is called a number of sufficient magnitude. And he mentions this out of thin air. I'm going to explain this now. So 20% into the book, and he hasn't began to solve the problem of explaining why we have 3 dimensions. It says here, dimensions, as if I didn't know about dimensions. So chapter 2 seems to be just about to tell me how ancient classic geometry works. It mentions here, let me see, it mentions here Pythagoras rule, which is obvious. It is obvious. If you don't know about geometry, I'm sorry for you. You're missing a big party, right? And let's see if it goes on from there. No, it doesn't. I'm just moving pages here, and it mentions space-time, and it has an image of an octopus with wings, and this is 25% into the book. And this is a book that's supposed to be a very smart book. It's recommended by professors in universities. So let's go on here. And then chapter 3, the geometry of 3 dimensions. Wow. So 26%, and it hasn't even began to answer the question. So it mentions polygons, and alright, and tetrahedron, cube, octahedron, dodecahedron, which it has 12 faces, and icosahedron, which has 20 faces. And probably people with with experience with role-playing games know about this already, right? 20 faces is like the dice of 20 faces. The dice of 20 faces is called a icosahedron. And it even shows some RPG dice here. It says RPG dice because dice is plural and singular is die. And then he mentions the platonic solids in higher dimensions. Let's see. Wow, nothing. So, I'm just looking at this, and I know I'm making a promise here, and I'm really sure that I can do a formal refutation on the beginning of Principia. I can do a formal refutation about this book. I can do a formal refutation about Kant's theory, and it's all up to people to accept these proofs, right? You know, they can always say that, wow, man, this man is just some unhappy dude. But am I unhappy? Let's find out. Let me see. The idea here is to, you know, keep talking for more 3 minutes at least. I'd say like for at least 5 minutes. Yeah, to make it 20 minutes. 20 minutes is, by the way, the time expected to be your attention span as an adult. Okay, so if you're having trouble to listen carefully for 20 minutes, you should probably rethink your life. You should probably go to the doctor. You should probably take a cup of coffee or something. I don't know. You should probably stop doing things as you watch this. Right, what can I do here? I won't pause the video and pretend I didn't. Just keep talking. Alright. So I have here as well a book about Wittgenstein. And I hope that I'm not introducing new names here. I hope that you guys already know about Kant, that you guys already have some ideas about Newton and his book. I hope that you guys have already thought about the possible explanation on the 3 dimensions that we see in physics. You know, I promised that I promised that I would come up with a logical explanation for that. And how can I do it? How can a 3-dimension person explain to other 3-dimension people that a 4th dimension is impossible? At least when you talk about geometry. I would have to use optics, I think. You know, for example, we know that 3 dimensions are the unit of a 3-dimensional system is a cube, right? That's the unit. And by the way, if you don't know about this, that's the unit of reality, right? The smallest particle is necessarily a cube. Okay, if it fills the smallest unit of space as well. And what about time? You know, when you talk about 3 dimensions, you can think of matrix with 3 rows and columns, like a 3x3 matrix. And if you're familiar with programming, you can think of arrays, which is, I think, better, maybe. And do you really think that's a correspondence to a 3-dimensional system? You know, you are reading a code about an array in a monitor which is built in 3 dimensions, and you don't know, and you do know that that's a very complicated way of describing a system that you could understand visually. Alright, and the thing here is that you can write very complicated but also meaningless stuff, right? What about the fact that I can talk about 20 dimensions? You know, I can just write an array with a proportion of 20 by 20. You know, that's not the point here. If you're doing 20 dimensions, yeah, I guess you're talking about an array in 20 dimensions. But does that correspond to 20 dimensions? That's the point. Is 20 dimensions geometrical? Wait, it isn't. So what about Pythagoras' rule when used on arrays? Does it work? What about when you were using the Pythagoras rule and you get a irrational number as an answer? Does it work? Doesn't that imply that it's not an exact solution? Yeah, it does imply that. Otherwise, it wouldn't be rational. Maybe I should make a video that's longer than 20 minutes here. because I'm getting really interested. Okay, so my plan here is to talk about something else as I try to solve this problem. So I will be typing on my keyboard and talking about something else. What would you say is necessary to go from classic geometry to three dimensions and to the third dimension, right? What is necessary here? I think that the appeal of 2 dimensions is simplicity, okay? And I don't believe in the existence of 2 dimensions. I do not. And when you're talking about 2 dimensions, what you're doing is talking about cubes with no height. Necessarily they're cubes, right? I mean, there is a whole system, a third dimension, and you can say it exists and then say it doesn't exist, right? If it exists, then it necessarily exists for all the moments that you could be talking about it. So I'm just typing gibberish here as I try to solve it. I mostly focus on how to explain that. Okay, so let's talk about this. We talk about the 4th dimension and 2 dimensions because mathematics, right? But mathematics is built around real things, right? And when you get a root of 2 as an answer to a Pythagoras problem, it means that this problem doesn't have a solution, doesn't it? Or at least not an exact one. Or maybe it does have a solution in real geometry, which is different from human geometry, for example. And if anything, we can only rely on real geometry, and real geometry is necessarily observed in reality. Okay, it's necessarily 3-dimensional, and it necessarily relies on the measurement of the sides. If you're talking about the triangle, of the sides of a triangle, it's necessarily determined by measurement. Okay, let's say that there is a difference between the 2D irrational geometry and reality. Well, if there is a difference and the former is used to be applied to reality mostly, then it really implies that any difference can be discarded, doesn't it? And when you're talking about a root of 2, for example, it means that for any approximation of that number, when multiplied by itself, it will be either smaller or bigger than 2. Okay? And what if we do that? I mean, how do you know the root of 2? Okay, and you basically have to choose between 2 numbers. And when you measure in reality, it can only be 1. So which one is it? Is it the smaller one? Is it the smaller approximation? Or is it the bigger approximation? Doesn't that imply that the idea that you have to choose between that you have 2 results for the same problem, doesn't that imply that the way we're doing mathematics and the way we're doing geometry is wrong? And when you think about 2 dimensions, you actually think about 3, and the third one is simplified, and that's the appeal of 2 dimensions. And the appeal of 4 and 5 and 6 dimensions is the complexity, right? But necessarily, what we must realize here is that these dimensions exist only in human mathematics, and human mathematics is yielding 2 results, when in reality it can only be 1, right? So which one is it? That's my question. We would like to empirically determine that, so I guess I'll just stop the video here.